Hello, test the microphone. Hello guys, welcome to another session. We will be doing Golang today. Today is Golang Day. So what I'll be covering will be majorly introductory session into Golang for backend web developers. So let's get into it. Okay, so I'm trying to hit the record button on my own system here. We should be starting right away. There's a couple of things we'll like to cover. By the way, this my ID is TRAE, Tira ID. So there are a couple of AI ID out there floating around, and I will recommend that you use an AI ID. It's gonna make your life easier. That's the idea of the whole thing, trying to make development easy for you in majorly. So without further ado, let's get into why we are here. So majorly, it's supposed to be an introduction to Golang. You asked me what is Golang. Of course, if you check it out, you would have known what Golang is. But if it's your first time hearing Golang as a programming language, Golang is also known as Go. It's an open source programming language created by Google. So it's major fact about it is that it's simple to learn. So once you start it, you guys will see how simple it is. You can get going with Golang within a week. It's fast to compile. That's one of the most attractive thing. It's for me is the fact that it is a compiled programming language. I'm coming from um, a programming language where you have to interpret that is not compiled, that interprets line by line. Interpret means that every line will be executed at runtime live. That's when that will happen, right? So you will appreciate what that means when you're dealing with compile time. We'll get to that part later. It's also powerful for building modern, software. Gen Z kind of people. So in terms of when we're looking at simplicity, Golang is a language used to build fast and reliable application, especially backend like API. And that's where the focus of all these things we are trying to do will be get from. We'll be focusing on more on API. It used to do more than API, by the way, but the focus was majorly for networking. That was when they were creating the programming language. It was geared to use to design network stuff. Well, API, not necessarily API, but of course, network is close to API, and there was a need for it because, as you guys know, there are all these other programming language like C++ and C language. These are old programming language that requires more work to be done on them in order for you to keep your code secure or safe. So when I mean secure, it's not like from praying eyes. It's more of like making sure that you don't have memory leakage and what have you. So, so what are the key features of Golang? What makes it special? What makes it stand out? I've made mention so many things, but I will just still talk about other things. Before we continue, let me create a folder. That's where our project will be, so that I can be typing one or two things as we go ahead. So my root directory is going to be inside, let's say, my base folder, and I can just say Golang go app. That's what I'm calling. That's what I'm going for. So this is my Go app. I just want to have a README file, README MD, and the idea is that's where we're gonna be, putting more of like what we're saying, so that you guys can see what's going on as we talk. We look at the features where we are, and then we go ahead, in other parts of the system. So we're looking at the features of Golang. So what are the features of Golang? And I'm going to be talking about them. So I know you can't wait for the code, but don't worry, the code is coming. So Golang is fast. We've overemphasized this like several times. It's fast. We can't you guys will say it. It's fast. And then there's concurrency. So the idea is that it do many things at the same time, and that's where I have issue with Node.js, right? Yeah. So yeah, even though Node.js is single thread CPU, so that's why I have issue with Node.js there. And for me, it's consume data a lot. So it has simple clean code. You will be the judge. You will be the judge once we start doing that. It has built-in tools. So what that means is that the tools are from Google themselves. Most of these things, sometimes there are third parties that do stuff for you, but Google did a very good job in making sure that this programming language comes with its own tools out of the box. It's safe, and then it's cross-platform. Wow. I have a story here about the cross-platform. There's a project I did, and I tested that project in major programming languages. First of all, I started that project with Python. Python didn't get me going. I couldn't, complete it in Python because I wanted this application developed in Windows, right? I was using Mac and I want to deliver the project in Windows. So I did it in Mac, working while in Python. Of course, Python is also cross-platform, but there's something you call true cross-platform. That's opening another door for other arguments. So I was able to push it to Windows, but it was buggy. Okay, I tried Java. Well, we all know Java is cross-platform. Java didn't do a job for me as well. It couldn't even get running. So I turned to Go. So Go worked well for me. I had a better experience using Go than every other platform that I've talked about. So the idea is, what can you use Go for? Because yeah, we're advocating for Go. So what can we use Go for? Even though we know why we are here, we are focused on API. Let's just put that out of the way. So for RESTful API, by the way, RESTful API is a type of kind of API. There are different type of APIs out there. So this is just one type. So it's used for RESTful API. It's used for web services, like a web server. So this is where you go for like backend stuff, right? Even though you can call API backend too, but most times when we talk about backend, it's not necessarily only API. It contains more than just API. It's also used for microservices, command line. So command line application are those things you use in terminal. You just put in those codes and then it does what it needs to do for you. Then we have cloud-based application and networking software. So the networking software was actually one of the major things that it was created for, but it has been used to do other things actually. Now, it has been used to do other things. So it has been used to do other thing. Okay, my sound didn't come out, so sorry about that. So let's move on to the next thing that we have here. We're just still talking about the whole thing, so you've not missed a lot. Okay, that's what it does. Now the next thing we want to talk about is, yeah, we've talked about this. How do we then install Go? How do we install Go? Because you guys will be working on several, I don't know the system that you're using, but I'm using a Mac. One of the first thing I try to get people working with is making sure that they have Brew. So if you are on Mac, make sure you have Brew. Yeah, and there are several ways in which you can install Golang. So let's look at the official site and then pick it up from there. From the official site, you can just download it and then install it. It's pretty simple to install. So if you have Brew, you just need to do Brew install Golang. It's as simple as that. Go rather, not Golang. So it's as simple as I already have that installed on my system, so I wouldn't go ahead with it. If you are using every other version like Linux and what have you, you have to follow their own procedure. It's pretty simple. Just go online and then you see how to install Go. But this is majorly tied towards using Mac OS, so I'm a little bit biased in that part. So we are not done. Installing Go does not really do anything, easy like that. We have to do other things like checking where the Go is installed. That's one of the early adopters of Go suffer a lot in terms of the path where the Go is installed. When you install a package like Go, you have to know where the path is. Not that you have to know, the system itself has to know where Go is, so that when you type a command like Go version, for example, the system will know, oh, Go is like the keyword, for example. Now it has to know that, oh, Go is a package or it's a program I have to run to execute something. So there's something we call Go root. Yeah, so Go root is like the root directory where Go is installed. And if you have experience with other programming language like Python, you will know that, rather like Java, you know that there's something called Java root as well, where you tell the system where the root directory where the JVM is installed and things like that. So it's the same thing with Go, where you need to set the path as well. You can also check the path that you have available. So most times the Go path is located inside your root directory. So let me see if I can show where mine is. So this is my main folder. So I want to get my entire root. So most times all my code is inside my root directory like this folder. That's why I put all my code. Okay, let's go on. Let's move on to the next thing. So we have our Go like that. So let's look for where our Go is. So let's talk about the Go part, because I'm sure you are going to have issues in that part itself. So Go part is an environment variable that tells Go where to store, all the things we'll be doing, because Go itself is a programming language that you can install packages with it. So we'll still be looking at where my own is later on, but let's talk about it. So you use Go part to download packages. That's where packages are downloaded to. And any binary that you execute or compile goes to the Go part. So let's look for the Go part on our system. To look for the Go part, you do Go environment, even though I've already installed this stuff. So you do Go part. So when you do something like this, yeah, that's what I was trying to look for. So it's in users process guy / Go. That's the folder where it is. And that's what I was trying to look for here. So I have to go through my user directory, which is, so I have to locate my user. Let me go through. Yeah, so I have to go through home. Yeah, this is it here. Then I go to Go. That is where my Go part is. You can see the bin and packages. Bin is a compiled version of tools that you can install. And you guys will see, we're going to install some tools so that we can use. You will notice there are quite a number of tools here. So most of them are by Google. So Google have this tool that it uses to help its own programming language. So there are other tools that were injected there by third party, and we'll get to talk about it, especially this air. Don't worry, we're going to talk about air soon. So these binaries are executable program that you can call up anywhere in the entire system, and they will run for you. So packages are other things that you do. Even your code sometimes can be here, but most times you can put your code any part in your document. Like this code we're working on now is Go app is here, although we've not created any Go application. So, but I have other applications sitting right in this directory. So they can be anywhere in your application, not necessarily have to be in a specific folder. So that's our Go part, right? And then you need to let the system know this Go part when you are done. And how do you let the system know? What we mean by the system is more like your terminal, because this is a terminal, as you guys can tell, and your terminal has their base configuration. Base configuration as in what the system will load with before it shows what are the parts available. So how do I get all the parts set up, or how do I set this part as part of the section that this terminal will look at when I'm executing anything? So when I type Go, for example, when I type Go, you see this terminal here. This terminal has some parts it's already watching to know, to say, oh, where will I go and search Go for? Or anything. It doesn't have to be Go. It can even be Python. I'm sure you guys know Python. It can even be Python, or it can even be Java. I don't know if I have Java on my system, but let me check. So I do have Java on my system, so I didn't put, the command line to follow. So even this Java that I just typed, right, requires the system, the terminal, to know the path to go and look for. So for starters, you will need to also set that path in the terminal. So how do you set this path in the terminal? So let me clean up this terminal and come up with a new one so that we can have a clean view like so. So how do you set the path? First of all, you need to know the path you want to set, which is this. This is the path we want to set into the terminal. And the next thing you need to do is to now open, there's a file on your system, which I don't know where it is. No matter which system you are, there's that part that loads. We have several terminals, guys. So depending on the terminal that you have will determine the path or the folder that you need to edit. So I'm going to open I'm looking for that file, by the way. So the file is not as if it's unique, but it depends on the terminal that you're using. Most of the time for your Mac, you're going to be using bash rc also. Now this is my root directory and I'm looking for the file right now. Not here, this is not my root directory. I have to go to that process guy. That's this part here, this section. That's here, user process guy. So I have to navigate to that section. You can see we're not doing Go yet, but still trying to talk to the installation part. So I'll go to my home, then I have the process. So the file I'm looking for is around here, but there are things hidden on my system. So immediately I do this, I can see hidden files. I know it's a little bit tiny, but just bear with me. So this is one of the file. This is ZSHRC. This is for a different kind of, I told you there's bash, there's ZSHRC, depending on what you are using. So I'm using this one. If I open it up here, you can see that there are paths already set. So this is Go environment path. I did mention that depending on your path. So this is, I use Homebrew to install Go. So Homebrew manages some of the things for me. And these are other things, by the way. So these are advanced stuffs. You don't need to worry. So that is set. Not that you can manually set the path yourself, or you can write the code to set the path. So how do you set the path? I'm not going to execute the code here in order not to execute on this. I just do something like this. So I export my home/go. Remember that the path is this. So home itself, when you print home out, it gives you user/process guy. So then you put your Go, that becomes the path for your Go path, and it's set inside here. I know there are other things, just ignore these other parts for now, ignore them for now. So this is the one that's for now that is important, the Go part. The rest, will automatically figure themselves out. So let's move on to the next thing, and this is for Mac. If you are using another platform, good luck. But they are pretty, close to how you can do it. But I'm sure now you understand why we need to have the Go part set, because we need to find a way for the system to be able to call the Golang code. Like when you put it in, it will know what to do. So let's look at the tools that we have. We are talking a lot about theories here. So we are still getting to the code. Don't be in a hurry. So let's look at the tools of Golang. What are the tools that you have? What makes it interesting is the tools that Go has to offer. So we have the Go itself. That's that one that you saw us did here. That Go that we wrote, and then we're able to do stuff. It's a tool that allows you to execute a program. Yes. So we have, in fact, the AI has brought quite a lot number for us. We have format, we have lint, we have test, we have build, we have run. For those of you that are very familiar with Node.js, lint, build, run, right? This is built inside the programming language. You don't need another framework to run your stuff for you. It just works in this format. So we'll be using some of this. I won't spend so much time on this part. So now that we've talked about this tool, we now need to talk about, before we talk about the external tool, let's write some basic programming code in Go. So let's write basic things so that I don't bore you guys. So let's do some example on how to do that. So before you go ahead, there's a way, or there's a style in which you have to create your Go code. You can't just, immediately just start writing code. You can't just say, oh, you have main.go and start writing your code. It won't really work that way. You will say, this is becoming complex. No, don't worry, it's not complex. So it's because of the modular way that Go sees things, right? Things has to be properly structured. So that's why it's like that. So how do we go ahead writing, creating, initializing our Go program? We use module. So this for blank projects if you don't have anything yet. But if you already have something, you will need to have if it's already come with a project, you don't need to do this, you just need to continue. So look at this like when you are doing npm initialization. The reason why I'm going back to Node.js is I'm sure many of you are coming from Node.js environment, but if you don't understand what this one means, also don't worry. Now, how do we initialize our project for the first time? So we do go mode start from module, initialize. Now this initialize allows you to now create a package name. So what do you want to call it? What do you want to call your program? For lack of a better word, I would just say Go app. That's what I want to call it, Go app. You can call it anything. So I'm just say Go app. And then once you do this, it creates your module for you called Go app. And then we have it inside here. And this literally we can just write ourselves, but I didn't want to just be creating things myself. I want it to just, happen and then explain the whole thing, the whole magic and what is going on. Even though this might not be the, ideal way to create this module name, you could actually do some interesting things. Most times if your project is going to be on GitHub or you have a repo ready for it, there is also a better way to do this. So let me explain what that means. Yeah, this is fine, but you will also see it in other formats like I'm about to do. So I'm about to delete this and recreate it again. So instead of me doing something like this, I will say http, or rather I will just say github.com/your username / the project name. Now, this is especially if it's something you want to host on GitHub or it's a public repo. Even if it's a private repo, you can do something like this. Then you end up with stuff like this, right? So, but the first one also is not also bad. It's good. And you can always rename this stuff to whatever it is and then continue what you are doing. But by the time you've started this project, or if you start manipulating this directly, it's going to affect all your code. Okay, so let's just stick with the Go app thing and let's continue with what we are doing. Now that this is done, you can then continue. Notice the folder name is called go.mode. So this one, so look at it like I mentioned, look at it like when you have your what's that called? .json, package.json in Node.js. So look at it like something like that. And the purpose of this file is to manage all your packages. Yeah, so you can do go run tidy, you can do go mode diagnostics. This is supposed to be used to check what is wrong with your module or your package. I don't know why they didn't call it package. Why did they just call it module? Okay, they wanted to do their own thing, but I think package would have been nice. Then run go mode tidy. Tidy is to just clean things up. You will see us using them, in the future. So let's go up to the next thing, which is trying to write Go code itself. So let's create our first file, which can be anything. You can call it anything. I'm going to call it name.main.go. Our Go, of course, is having extension of Go, but this other guy is having extension of mode, just for you to see the clear stuff there. Yeah, I'm just going to be writing a very, plain and boring application just to say, let's see, welcome to your first Go project or something. Let's just write something as simple as that. Now, the first, stuff we have here is we have two keyword package main. Now, this is not a keyword. This is the name of the package that you're entering. And we want to use a particular extension or module. So just to give you an example of how things work. Of course, we can run it without doing anything. So let's do it without doing anything so that you can see how it goes. Let's go as bare minimal as possible. Guys, please use AI. Use AI as much as possible. So even if we try to go as bare minimal as possible, we have to import FMT. FMT is a format package manager or a module that allows you to print, stuffs on the screen, on the console. So there are like tons of other things. So this is just your first function or your first package you'll be introduced to in Golang. And it does what it is that it's supposed to do. It's just to print hello world, nothing special here. So let's go ahead and see how to run this guy. So to run it, you will need to go by doing, so who can guess how to run this now? Go. So you do go build, and what happens? It builds that code for you. That's it on the left hand side. This is the application here. Of course, is executable application, and that's one thing you need to know what happens when you build your application. I did mention advantage of Golang is that it's a compiled application or a compiled programming language. Before you can run an application, you need to compile it to an executable format. So what Go build does is to compile it to an executable format, which is available to us on the left-hand side. Now, once it's compiled, if there's any error, it won't compile. Maybe let me introduce something here. If there's an error here, let me delete this one and try to run it. It won't compile. Of course, it's going to tell us we have syntax error. You will not know the beauty of this until your code is in live production, or because if there are errors, you shouldn't get to be able to compile any code. That's one of the advantage of compiled programming language. But the downside of compiled language is that it's slow. However, Code Fusion is, or rather, Golang is an exception to that rule. Golang is very fast, and that's why most people, get towards using Golang. Now that we've been able to compile this, how do we then run it? So you just do go run main. So once we do go run main, now it didn't run because there are some things that we missed out, and that's the fact that we have issue here. So we have issue in this part. So let's see. Okay, so I think we're supposed to do go run main. Yeah, we're supposed to add the go extension. Okay, so there we go. Now we might not necessarily need to build it before we run it, but I will explain why we build it. Now, the idea of building it is for you to be able to use it outside of this project. Now, you could run it without building it. So let me go ahead and add another thing. So let's run it again. Without building it, you can always run it and then it will work. Now, why do we need to build? What's the purpose of building? The purpose of building is for you to use outside your system, maybe for another person, or let me show you what that means. Remember when we built the first one, we didn't put good, right? So this is it here. When I open the file, or let's open it in a directory, reveal in folder, this is it here, and it's 2.3 megabytes. So this will only work on a Mac system. This is an executable file. If I execute it, so how do we execute this now? So I'll just drag it and drop here to execute this code for us. So you can see it says hello world. It doesn't put a good there because that was the previous one that I did. So this is now an executable code that you can transfer to anybody to use. So if this was an app or a server or a backend or API protocol, whatever, you could build it on the server and then you run it. Normally, you don't run your program like this and say, go run main, right? You build it and then you run what you've built. But because we're in a testing environment, you can always do go run main.go and then you are good to go. Now, another thing I want to explain is the fact that how do you enjoy your development, or how do you go about your day and making sure that your development is continuous, consistent? There's no break. You don't have to be run main.go every time. So let me save this now. I just save this to ... And it means every time I have to do this to see my results. That's what it means. So if I make a simple change in my code, in my program, I have to run this every time. So what tool can we use to make this development easy? We call that hot reload in React and other tool, whereby once you make a change to the source file, it reloads in your entire application. So let's see, what tool can you use? I told you something that we are coming back to air. So let's look at air. So we'll even look at the site so that you can see the usage and everything like that. So let's go to the website and see how it is implemented. So it's one of those early code I actually found out. It's very, very nice. And if you are using Golang and you're not using air, you're going to be missing out a lot. So the endpoint, this is the site. Very nice approach to, and it makes your life all easy. So this is what we want to install. Live reload for Go apps. Like it reloads your app as when you run some stuff. Of course, we're going to see the process and everything. So this is how to install it. Very easy. And this is not just only how to install air. This is how to install any package you have out there. So I'm going to show you the format. It's just saying go install this guy. Go install this guy. So we'll be doing a couple of other installations. If we have time, we might also go into Swagger. So we'll also do code documentation, right? We'll do Swagger as well. So you see how we're going to install another one. So this is how to go about it. Go install this and that. So most times, if you have the URL, right, of the code, like the Git CLI, platform, the HTTP, you can use that to install the package itself directly. Okay, without further ado, that's the only thing you need to do to just install that, and you don't need to do any other thing again. This is just one single command. I already have it installed, but let me run it again so that you see that in action. So I'm gonna copy this. Let's give it a try. Then I just do go install. Since I have it, I won't have any other problem again. And you just need to install it once. You are not installing it specially for your particular project. You are installing it entirely on your Go structure. So that's why I said that it's also installed itself as a package or as a tool that you can reuse. So this is the installation and you are good. It has everything going for it. And the command line to use your Go, your new air, your code stuff is to do air. It's as simple as just saying air. So once you do air, you saw this in their site. So it just did this for you. It tells you the version of air you are running, built with Go 1.25, and then it's watching your application and it's building, it's running, it's run this. Now the reason why it terminated is because we're not running a web server. So if we're running a web server, it will not terminate, right? Anytime you make changes to your code, it will keep running. It will keep refreshing. The reason why it terminated is because we are running a command line application. Literally, this is what command line application is. Once it's finished running, there's nothing that is keeping it from exiting. They call that interrupt. There's nothing interrupting the exit, and then it goes off. So that's why it terminates. There's nothing for it to linger. But when you're running a web service, it doesn't terminate. It's running, right? Waiting for request, waiting for you to hit a request. So let's see what we have next in our lineup of things we're talking about. Now we've looked at basic code, so let's look at some basic code in Golang. Let's get ourselves used to Golang. All the thing we've been talking all this while is still talking around the structure, the environment. We've not really seen the whole coding architecture of how it is. So let's start talking about it now. The first thing we're introduced with is the package, and that's to tell the file where it is. You can't do anything without the package. The package must feature in any file that you open. So if you open a new file, you have to say where you are, right? The package. So yeah, that's the first thing. The next thing that follows is all the things that you need, just like Java and C and C++. All the code, even in Python, yeah, you do that in Python as well. So you import quite a lot of tools. So most times you will need all these tools to do stuff. So any tools that you've referenced, you have to import it to be used within your code. Now I'll start with, one of the easy things is, the arithmetic stuff. It's pretty, not really the arithmetic stuff, the variable declaration. How do you declare variable in Golang? So you use, is this guy listening to me? It looks like the AI I have installed is listening to me. I didn't type anything, and then it gets to know what I'm going to do next. So it's the variable kind of a thing. There are two ways in which you define variable. You either use the var keyword or you use assignment. So you can either use this var, or you create the variable and you assign a value to it immediately, like this. So let me use the to method of how to assign a variable so that you understand what's going on. Now this is the first form in which you can assign a variable, and we are saying type. We'll go to the data type later. There are various data types, but let's just still talk about variable declaration. So this is you declaring a variable. This variable does not do anything yet. You're just saying you want to use a for something. That's the idea. And at some point you now declare that your a is 1. Now the reason why you're having this underline here is that you cannot declare a variable without using it. Yes, for those people that, okay, I was looking at Rust as well. Rust is another programming language I would like to do in the future. So yeah, because the idea of variable helps with memory management. When you're declaring a variable, you're taking a piece of memory from the system. So you have to use this thing, guys. So don't just, put us under pressure by just declaring something you're not trying to use. Okay, of course, we're going to use it in our output here. So another way to declare a variable is, let's use another method for declaring a variable, is using this method. This is the same method we've just literally used. So I want to show you the third method, and that's saying sum is equal to this. Now look at the way I use this method. This one was not declared like 1 and 2, like A and B. I didn't use the var keyword. When you use the var keyword, you need to specify the data type. When you don't use the var keyword, you need to use this column here. This column says it's more of like a shortcut for you to say var. However, data type does not matter because you are assigning it to something. Since you are assigning it to something, that thing you are assigning it to, it automatically inherits the data type of that thing. That's why there's no need for data type here when you are doing something like this. Of course, the reason why it's underlying this is because we need to use this sum somewhere in the program. Okay, so how do we make use of this? I will say this is my sum. This is a variable, and this guy receives endless parameters. So let's look at the first function. Let's divide this function, or let's dice this function, this format fmt println function. So the way, okay, we've not got into function, but let me just use this opportunity to talk about function and how function works a little bit. So we have where we have a parameter passed on top of here. You can see that parameter section where you can pass any kind of parameter that has any number of data type and number of entries. So that's why you have ... any. meaning it's not just fixed to one data. That's why we were able to pass two parameters. We passed like a string and we passed like an integer. How is that possible? Because the print function accepts unlimited number of arguments and also unlimited in different types. Okay, so and it returns this. We'll talk about functions later. Okay, so we've not passed the second guy, so we say sum. Of course, when we run this, we should see our answer equals 3. So notice something, that the code executes itself. I did not click run. I did not click run. I did not do anything. So let me make an adjustment to this and add 20 and say 27. I just need to come here, and since the system sees that this is saved, it just compiles it for me and executes it like so. This is what air does for you. I don't need to write the code, go run. I don't even write it. That's why if you guys noticed when I was running, when I had an error the first time, I'm not used to writing go run main.go. I'm not used to that. I just type air and I'm good. So it has spoiled me to the fact that I didn't even know the syntax to run the Go code. So you just do air and you're good to go. It makes life a lot easier. Yes, that is introducing you to variable declaration. Of course, you can work with string. How can you work with string? You can use the same method and say, hey, I want to say title and call this string. Just the same way we've declared that this is this. So you have the var, the name of the variable, and the data type. Data type is another story for another day, right? There's obviously, data type is very, very big. You need to dice and break all the data types. So we don't really have time for data type now, but let's just take it gradually. The simple ones are string and integer. Okay, we still need to go into backend API in this live session. So we still have quite a lot to cover. And the same thing we've done here, we can use it to replicate what the title will eventually be. Or you could just do the shortcut and say this is equal to the sum of two numbers. You can do something like this. This is fine. And the reason why this is underlined is because it's not being used. So if we want it used, we do something like this. So as I save, it gives us this for us. So simple and clean. There are other things you also need to, think about, which is loops. Obviously, loop are something that you cannot run away from in programming language. You need to know how to write loops. So let's see an example of a loop. And the most common one you will use is, this is a very, I think it sees itself in all programming languages, if I'm not mistaken. And that's your infamous for loop, where you have for I is equal to, so you can see what I did here. This is like I automatically initialize this instead of me using var, and I terminate using a semicolon, and I say my I is less than, you guys should know this one by now. So you also terminate, and you need to also have a way to increment your I, because you are saying your I, of course, our AI is doing that for us. That's the point of having AI, to be able to do some stuff for you. And then you have something like this. Let's just print this out. So we can say you should do, let's sum two numbers together. We have the I, which can automatically come here, whatever the I is, then plus, let's just say I plus I, and whatever we get, we should have it. So we can remove this sum here. It's not needed. We didn't use any of this, so we need to remove them because these guys are eating memory. You've used a memory that you did not work with. So this is it working, guys. So this is loop for you. If you are comfortable with this type of loop, this is what you need to use. You need your initiator or your initialization, and then your condition, and then your incremental value. That is set. There are other advanced stuff. Remember what this is all about. This is introduction to Golang. Now let's see what else we have lined up for us. The next thing is, how do we do backend like API stuff, like the real deal? These are still child's play. How do you go ahead and start, running a server? How do you do that? So we're going to be using a guy called Gene. So again, I'm going to go to online to show you. One of the things about this stuff is most times you don't need to create stuff, yourself. You can just rely heavily on what people have done. So let's go to Gene. Gene is very popular. It's the most popular backend stuff for Golang. It's very popular. So you can't miss it. And you have other backend architecture. This is a web framework. You have other ones. In fact, one of the interesting thing about Golang is the fact that it has its own inbuilt library for this. So you don't necessarily need to use, Gene, but of course, these guys come with advantage for using them. Okay, so we'll go to how to get it running. The same method that we did is to install. It's a little bit different. So if you import it like this is the importation of how to start using it. But of course, you will need to install it somehow. Remember Node.js. I still use Node.js, as an example, because that's one of the easy way you guys can understand what's going on. In Node.js, let's open another terminal and see. So what we want to do right now is to install Gene. So if it was Node.js, you will say npm install Gene, right? This is what you do in Node.js. But in Go, what you do is that Go has a mechanism that automatically connects to GitHub. Not just GitHub, there are other repo as well. Of course, that's what even normal package manager does. They connect to this third-party repo so that it will check for the name and it will use the name to install it. But the way this one works is you have to put everything in full. You have to be explicit, guys. That's what it's trying to say. So you can either use this, go get this, or you can just import it and let Go do its thing. So sometimes Go will install it for you automatically. Sometimes. So let's try and see if Go will install it for us. So we have this. This is where the old Gene is. This is the full directory. Now, do you remember when Anna told you that your creation of your package or your module should look like this? This is the reason. So if you are creating a module that you want people to reuse, so it will be good for you to say that it's this, your own name, and then your package name. This is the benefit of having something like that. But of course, if it's a personal or close project, or it's not even a module on its own, you don't need to worry about this name structure. Okay, so if we now want to make use of Gene, we can just import it like so. Of course, it's gonna complain. Could not import this guy. One thing. So we're not gonna see anything usage here. If I save it, it's not gonna work because the system didn't see a need for me to use it here. So there are several ways we can go ahead and keep writing to the code and expect the system to get it for us, or we can just get it and then use it anyway. So let's go ahead and see how that will work. Okay, so let's see. Now that we have our directory, let's go ahead and use the alternative way to get it working, which is to do go get. So what are we getting? We are getting this application, this module, that's GitHub Gene gonic/Gene. So once we do that, it installs it. You can see that it's downloading it and it's getting the latest version. Of course, it didn't tell it. If you want a specific version, you can do and specify the version that you want. But if you just do it like that, it's gonna get you the latest version. Now it's installed, right? And the next thing you can do is now start using it in your system. There are quite a lot of process, but I'll try as much as possible to break it down. In fact, the guy has started creating it for me. So the same thing, I didn't ask it to do all these things, but let's start from ground so that we can understand what it is we are doing. So I'm going to save so that it makes everything clean and start from beginning. The first thing you want to do is, this guy is still writing the code for me, but that's fine. So I have my own way of doing my own. So I'm going to call it router. So router are kind of the, how do I put it now? The endpoints that you want to create, you want to have access to. You want your server to expose to the public. So we're creating a variable called router, and we're now using the gene directory or the gene package, right? That's the gene. So immediately if I hit Control S now, it's going to import gene, because the system is going to look for that gene even without me saving. It's trying to bring it in. Now this gene is now recognized, and that's only because I've installed it. So this default is kind of a configuration that we can set up to tell the way gene should work. But for now, I'm just going with the bare minimal. Now, this router is what I'm going to use to specify the path I want to expose on my server that I'm about to create. As usual, it's just doing its own thing for us. So first of all, I want to do a get. That get means I want to allow the world to be able to get a specific endpoint from me. And the endpoint I'm looking at for starters is just, a root directory. So if you come to my root directory, you should be able to see something. So what do I want you to be able to see is, normally, to make it easy for people to understand what's going on, I will just put a function directly. Normally, you're supposed to put in a function there, right? So that you will be able to understand what is going on instead of just dumping all the full code there. So let me break it down into a function. So what it requires here is a handler. Now a handler is what this part is supposed to handle what comes in from this part. That's what the handler is. So what I want to do now is to create a handler for that part. So, and that takes us to how to create a function. We already know how to create a function because we have this function going on for us here, going for us here already. We already have a function. So let's create an handler. So we'll create a function. I don't want to, pack it inside here. It will confuse the whole code. I don't want this whole mess stuff to confuse. I want to be able to separate my code so that you guys see what's coming here. So I will say handle root, handle base directory, handle base. Let's call it handle base. Then, okay, smart enough to know what I'm trying to do. So the next thing is the context. The context is what is happening in the entire world, and it's putting it inside this C. You guys will see what I mean by happening in the entire world. Context. So this is just look at this as the format. So what I mean the format is that the get requires something they call handle function. The get requires what they call handle function, and that's what we're trying to create. And handle function requires you to pass the context. The context is what is coming from the outside world. Okay, so the outside world, is having this C, and then you can then say JSON, and all this parameter is being handled by who? By gene. Everything has it. They've already created those things for you in the gene package. So this is you just responding and returning. Let's see what is returning, guys. And returning this JSON objects. So it's more of like you're returning a string, so to say. Okay, so let's save. Now we had a new thing here, which is HTTP. So this is just a list of directory or list of response that HTTP can have, and we are getting that from net.http. Now, if you are used to REST is a protocol where you can call the backend system. And the idea is that there are requests that you can make, and there are response that will, be pushed to either the client or to the server. So there are different kind of response that can come here from the server. And this is used, being able to define the kind of response you want to return. There's a lot of them. Of course, because we want to show that this is okay. And that's why we are returning status okay. So because you need to understand why this is what it is. So it's not just that we are returning okay just for the, mere saying okay. It is because we don't want any error. If, for an example, this returns an error, you want to tell the user that, hey, there's an error somewhere. Let's see something for error. Maybe forbidden, status forbidden, right? It will return to the user, and that's what the user will see. We're going to give it a test. So let's go ahead and say status okay and move on with the remaining part of the code. Now, the next part is talking about what can be sent to the user in terms of the data. This is the status code. This is the data that goes into the body of the message that what the user is trying to request for. Now, I'm just sending a JSON object which says hello world, right? We'll make this complex later in time. So this is an object. This is the code, status code that you are returning, and this is the object. So this function is not being used. That's why it's underlined this way. Now remember that the format for this is just to have this. So this one is easily readable than what it was giving me before. I didn't want to combine these into this. So I like to separate it like this. Even in my main code, I don't combine this like so. I always separate it for easy reading. Now that we have that in place, now the next thing we'll have to do is to be able to run our server. How do you run your server for your server to go live? So you run your server by coming to the end of this part here to specify the port. So if I come to this, I think we are done with this section. So we need to run the route. Okay, yeah, that's it here. This is where you continue to execute your code, because what you've done here is that you set the server up for your part. Then you need to also run your server and make it available to the world by saying the port that you want for it to be accessible by 8080. Okay, so let's go ahead and run air, because I actually end that air the other time. So our air is running, and let's see what happens to our server. Now I have to make this, big so that you guys will see what's going on here. Now it creates an instance and everything. Normally when we are running this in a server mode, you have to change this to a release, but for now let's leave it like this. This is just showing you all the things you need to worry about, but for now, since this is your first time, it's fine to run this in a non-release mode. Now this is the path that it's registered, and then it's pointing to handle base. That's what the function that we wrote. So it means we can then listen where the server is actually running, and we can test it out. So let's give it a try and run this. So let's go by, is in our local host, that's 8080. So our server is working, and that is what we have there. Message hello world when we run that. So if you run something else, like say hi, notice the endpoints that I put there. So it gives us page not found, even though we've not created anything like that. It just automatically, instinctively created this by itself. So you have to now provide the endpoints on things you need to do. Now there are quite a lot of things you also need to understand, which this lesson might not cover, because I need to also talk about the basics of REST API itself. talking about get, post, the methods about REST API, the security layer, and what have you. So this is just to show you the basic form of how to use Gene. This is a basic form. The next thing I want to show is also, let's say if you want to post, for example, you can just do post this way. So I'm not going to fill up that. I'm not going to do any example on that one. So I'm just going to do one more example. And this is to say hi, to register a hi part. And I'll just say, saying hi. Oh, okay. So I can create another function. This is the first function I have. Then I'll say handle. This one will be handle hi. And that's how you go, guys. That's how you keep creating all the endpoints that you want available, and you create all your functions to be able to handle the endpoint that you've created. So now that I've saved, I just need to go and check my endpoint, and I will be able to access it. So if I do this and say hi, and it's saying hi to it. Now let's look at the next thing we want to go to, which is code structure and recommendation. Okay, so I won't really go too deep into code structuring because you barely understand. Of course, you've gotten the basics of Golang, and there are more to it than just what I've shown you. So I won't go deep into structuring of your code, but most times your code, all the code that you're working with is supposed to be in package. Apart from your main can be outside. You can have several folders, like pkg, which is your packages. That's where your brain of your code will sit. There are also another folder that can be internal, things that doesn't necessarily need to be exposed. There are other things like also configuration files that has to be of things that has to do with configuration that is private to your project that you don't want to expose as well. So there are different ways in which you can structure your Golang folder structure. So for now, since you are still learning the basics, we won't go into that. The next thing we want to look at is how do you document your code using Swagger. I'm sure we all know what Swagger is. If you don't know what Swagger is, it's a code documentation architecture for Swagger. So this one has a little bit of what will I call it now? A little bit of cock to it, like a little bit of things you have to do, but it's not too much that you can't handle. So let's look at it. The same thing, it also have its own site you can go and visit. Let's check it out as well. There are several tools on that you can use for Go. So I'm using this one. It's called Swaggo. Swag. There's quite a lot of them out there, but this is one I've been using and it's been very, very fantastic. So this is getting started. Very simple to implement, and we'll just go right into the usage straight away. How do we use it? The same method that we use to install our Air, we're going to use, because this Swagger we're about to install, or Swaggo that we're about to install, should be able to be used across your entire package, because you want to just have a tool that works everywhere. Just imagine the Air that we run now should just be working everywhere. We don't need to be installing it every time we need it. We just need it to install once, and then it's working everywhere in your program. So the first thing is that you need to install the Swaggo, and we use the global install. I will use this one as a means of saying global install. Okay, so you are doing go install this guy, Swaggo, swag, this. I don't know why it has to come with command. So it has its own final extension apart from this swag, because normally it's supposed to be this, and this, but it's fine because they have another thing here that is different from the architecture that they want you to see inside. Okay, so that executes, and while that is running, another thing you need to have is the main file for. So when we're doing Air, this is all what we needed, but for Swagger we need two more things. The reason because it creates files for us on the fly. It creates its own server. Not its own server. Yeah, it kind of creates its own server. You guys are going to see it. So we have two more things we need to do. And we need to go get Swaggo, Gene, Swagger. Because we're using it for Gene. So there are for other backend application as well, or web framework. We have several frameworks out there, guys. So it's for this particular framework here. So we have for other frameworks. So you come here and you install this. Just two. We're installing two. You install this one. And the next one is for the files. You install for the files. While this one finishes, let's install for the files. That's why I said this one is a little bit somehow, it's not straightforward. So this is the second one, and it's for the files that it's going to be generating. Hey guys, what we're trying to do is serious documentation, and you see the results. The results will actually, show that it's all worth it. So we did 3 installation. The first one is the command line that we'll be installing across board. Once we run one command line, it's going to generate the code for us. We have another second one that we installed, which is for the Gene, so I understand Gene framework. And then we have the last one, which is the files that it's going to be generating. We are not done. Because it's a code documentation stuff, anything you add to your code, it will extract the file and spit out code for you. That's the idea. So we're going to be adding some code. But before we start adding some code, let me generate initial file for this project. There's something we need to run to generate the initial file, and that thing is called swag initialization. Of course, not spelled like that, but you do init, swag init, to initialize the swag folder. This is a documentation library and it's expected to generate files. So that's why we went all to the trouble to have all these things. So once you do this, it's going to create a directory called docs. That's it there, guys. And the purpose of this, well, you see the purpose later. So it has generated this, and these guys will keep, you're not supposed to modify this code. This thing will keep doing its thing. This thing will keep doing its thing. Remember, we are doing code documentation so that whosoever is using your API will be able to consume it flawlessly. That's the idea. So let's move on to the next thing. We want to document this our wonderful code that we've written. Now, the next thing you want to do is to add this file. This file, we need to add it to this our import as what we are doing. Okay, so we bring it here by saying docs. We just bring it here by saying docs. Now, there's a way, because the system might not pick anything from inside here. Sometimes might not pick anything from inside here. So let me show you. So this is it. You know that this guys was generated automatically, and it's a package docs code generated by SwaggerGo. Do not edit. But I'm just entering this folder just to play around and show you stuff. So let me say this guy, for example. So if you wanted to use this guy, inside this doc, if you bring it up now, of course, it's going to be smart enough to know that, hey, this is inside here. But if you are not referencing this file directly, there's a way you need to, and you still want to bring this up. The way to go about it is by doing something like this. So once you do something like this, underscore and the package, you are forcing the package to stay. Hey, don't mess with what I'm doing. Don't mess with what I'm doing. Leave what I'm doing. I know what I'm doing. Don't automatically do anything for me. So that's what you're trying to do here. You're telling it to just leave this code that you're coming. You're still doing some things underneath. Okay, so let's go ahead and see how the whole thing works. So I just did underscore docs just to lock this guy in for now. So let's go ahead and see the next thing that we need to do. Now, the next thing is for you to read up the documentation and the process to documenting it. So I'm going to put a basic documentation, and that is here. To document your code, you will write, I think it will try and, good, thank you. The guy is listening to me. So it has brought out the code for me. I'm going to accept everything because I don't want story. So I'm going to explain everything to you. Now, the way Swagger documentation work is by you commenting in your code. And this is just comments. I'm just saying title. You have to put all these guys. That's another thing. All these at description, at this, at that, at this. Those are the way the system knows what to tie what with. So I'm just going to delete a couple of them. So I'm going to say Swagger example API. Okay, that's good. Version, description, I'm going to leave that one. Then I'm going to remove all these things. So not necessary. So you can delete as many things as you want. This is just an example, by the way. So we don't need all this stuff. So I can leave this one, base version 1. Let me say version 1. Okay, so this looks good. Now remember that there are several labels that I've deleted. So if there is something that is special to your own documentation, you can bring them back in, and then that becomes part of the documentation. This is just comments, and that's what this guy does. This guy will read all these things and create a page for it for other developers to be able to read. We are not done. This is just you commenting your code, but the comment is going to go into the documentation. So the next thing we want to do is to serve the Swagger page. We need to serve the Swagger page. So we've served this page. We've served this page. What about the Swagger page? Let's serve it here. Let's have it. So I don't know who is sending it to Oko. This is not how to serve it. So we do router.get, and this is how to serve it. This is just doing its own. Even though that's not how to serve it, I just have to listen to it so that it will give me all the things I need. That's not how I'm serving my own code. So you can we can even serve it this way, by the way. But something you should remember is whatever you put on this part that matters. You can rename it to anything. You can rename these to anything. You will see that what this is depends on what will be available to the user. So here is where you put your details. So all these files that you've put here, the handler, we need to go and create the handler part. Okay, so we'll get to this later, but I want to make sure that I've documented. This is just one documentation. You are supposed to document this one as well, and this one as well. So let me document the base part. Okay, so let's see why this one is acting up like this, because that part is not supposed to give us that problem. So that part is a little bit acting up. Okay, so we're missing one import. So we didn't import all the things that we need, because we also had to import. Remember that we installed the Swagger files. So we didn't import two things. We are missing two things, because I was wondering. This is one of the one that it automatically came in, but the other one didn't come up automatically, which is the files. So we didn't have the files in. So now this is supposed to deal with the file. And now we have that file settled. Now the other part we need to also worry about is, I mentioned that we did not document. So let me leave that undocumented, so that when we come back, we'll use that opportunity to document hello base and also handle hi. Okay, so it's still giving me this issue, but I don't know why it's not listening to me. But let me see if I run it, if it will listen, along. Now I've run this code automatically. That our air is running, so it will always run irrespective of what's happening. This guy is gonna go away soon, but maybe it's gonna still stick around for a while, but it's gonna clear off soon. Now this is the high, this is the docs that we have. So that doc is where our API is gonna sit. Let's go ahead and look at our API Swagger documentation, and let's get to it. So to get your documentation, you do your docs and you do your index.html, if I'm not mistaken. Good. So that's how you get to it. So we are getting some error, but we'll resolve it. We'll resolve that error. Okay. So this is the Swagger interface, but we're still getting some error. We'll go and fix the error. So this was the heavy lifting that the system was doing, that I was talking about. So let's try and get rid of the error and see how we can show the documentation itself. I know the problem will be here somewhat, but let's go back to the code and change some of these things. Let me check, because the one I have running live is Swagger and not Docs. So this Swagger, and so let me try this. This should stop working. That should stop working immediately. Okay. So I think it's serving the endpoints now. So what is happening here are the paths that is serving. So it's not getting this one. You will see that it's saying 500. 500 means that there's an internal server error. Okay, so this is where we want to run it on. Let me save it again so that it will recompile this code for us. Okay, so that has been recompiled, but it's still registering docs. I don't want it to register docs. So at this point, I'm going to stop it to run it again to see what then happened. I'm going to terminate the whole server. Yeah, and then let's run air again, because it's not supposed to be registering docs. The reason why it's registering docs is because of this error. It has not gone past this error. So let me see if it will build after I remove that. Let me now try and check out my API. Of course, this is now Swagger. So we're still facing the same issue. So the file that it's trying to find is this swagger.json. Okay, I think I know the problem. I think I know the problem. So let's continue. So the problem was from the fact that I did not run swag initialization. I didn't do swag initialize. So anytime you write your code like this, if you add new documentation, you're supposed to do swag initialize. You're supposed to run this. Now that I've run this, it generates this code and add more story for me. So notice that it has add more stuff for me this way. That's for running that. But that doesn't still fix the issue that I'm having here. So what I want to do is, this is where my issue is coming from, but we are gonna surmount it. Let's run our A again. And so let's check the error. So one of the error it's finding is that it can't see swagger.docs. So it can't see this one and it can't see this one. And it's because of our naming structure. So we need to change it actually to docs. So if we change it back to docs, it should see this folder for docs. Then all this should be changed from swagger to docs, I believe. Let's check. Okay. Now the good thing is that it found this, but it couldn't find this. So for now, I'm going to rename this to JSON for now. Or rather, I'm going to change this to doc so that it will match this one. So let me give it a try. So you didn't see this. I didn't see this. So the idea is that all these are available. Let's try to fix this. So let's fix this. I think the problem is coming from the fact that we don't have the doc in properly. So let's use our package name as well. Our package name is Go App. I think this is one of the things that's causing the issue. Yep, that should fix the issue. Let's give it a try again. So we have it fixed. Now we were supposed to use our package name like so to bring in docs, not just sit on doc like that. Now that we have it set, this is how your Swagger will look like. This is a sample API. Of course, we did not document any operations. So this is what you will give to the developer if you create your application. This is what you give to the API, the developer, front-end developer, for them to look what is going on in your code. So let's go ahead and document the operations that happens in the code. So I'm going to document this one. So this is where I need you to just give me the code. Good. So I don't want to go ahead and start raking my head on what to do. But the part you need to understand is that it has summary, it has description, it has a tag. You will see where the tag is used for. It has what it accepts, what it produces, and what happens if it's successful, and then the route that is calling. So automatically you're supposed to manipulate all these things to fit into what you want to tell the front-end developer. So I'm going to do the same thing here. Okay, good. It also generates everything for me and like that. So let's save it. But saving it will not just do the job for us. We are supposed to run what? Swag initialize. Whenever you create a new documentation, because the swag initialize is creating this whole thing for you. It's creating all these things for you. That's what the swag initialize done. And it's a lot. So let's go to a new terminal. Let's not mess with this one and do swag initialize. So it does what it needs to do. It has changed this our stuff to Swagger. This one will manually change to this. That's changed it to Swagger. But let's see if the Swagger thing will work, because at some point it was complaining that it wanted me to rename it. Okay, so I've saved it. Fingers crossed. Let's see if it will work. So yeah, it's working. So notice that we now have two things here. We now have our greetings. That's the tag. That's the purpose of the tag. The tag is a way for you to group endpoints, similar things together. So when you run your Swagger, you give your API to this person like this. This how it doesn't necessarily need to read Swagger. Let's change this from saying Swagger everywhere. So I'm gonna say so that you see that we have our own touch on it. My first example API. This is a sample API, blah, blah. So let me remove all this guy. Let me remove the license. And then, yes. So now that we've done this, remember you have to run your swag initialization every time. And by the way, there's a way you can do it that when you make changes, when your air runs, you should run your swag, with it as well. So you can also do that together with what you are doing. Now, if I refresh this page, of course, it's now being tailored towards my application. This is where you put the version information. These are the things that you can do. You can even try out the endpoints. So if you say try out the endpoints, it will say, okay, what am I supposed to put? When you execute, it's going to give you the endpoints that you have there. if you put the right thing. Now look at what is happening. Of course, it's because we put the base endpoint. We put version 1 in the front. Let me go and remove that base endpoint. This is what I've done here. So I said the endpoint is depending on version 1. That's why automatically the system add version 1 to my all the stuff that I'm doing. So base endpoint can just be like this. No versioning, nothing. You can just say it's like that. So if I go ahead and check that again, and so my base URL is endpoint / like this. So let's try this out again, and I try to execute. Yes, we have tested our endpoint successfully without actually using Postman, right? Of course, you can use Postman to check what you're doing, but the idea is that within the app, the system generates like this for you, where you can test your endpoint without Postman. You can put all the information that you want to do, and then you're good to go. So let's check out the hi as well. Try out. If it requires any parameter, of course, you can load all those parameters inside and it will accept it. You can use it to generate the same thing. It also give you a result like so, and we are good to go. So this is the bare basic of bare metal for Swagger. It does quite a lot. This is just the bare minimal to get you started. And that will be everything I want to capture today. So I will quickly go through comments that I have in the live session. And if there are interesting comments, I will address them. If there are none, we will just, call it a day. So if you have questions from your end, you can also shoot questions from your end from the Google Live. You can also shoot comment from your end. So I'll be expecting comment if you have any. So let me see if I have comments from the live session. So someone was asking if it is VS Code. This is not VS Code. So let me go way up and start the question from the top, so that I will cover as many questions. So one of the good thing about Golang is also good for WebSockets. That's for, what's it called now? If you want to do what's the word? What do they call this now? Like chat application for chatting, for collaboration. Yeah, it's very good for that as well. So that's another thing. So someone asked if I was using Cursor. So I'm not using Cursor. Let me show you the IDE that I'm using. This is the IDE I'm using, trae.ai. So that's the IDE that I'm using. They've started converting to paid version now, so good luck. But I'm not using the paid version, by the way. Someone said Go is the best language after Rust now. Okay, so it's not VS Code. So someone asked if they've learned Python, what's the next thing? If you guys have questions, please, you can unmute and send me your question so that I'll take your question live. So after Python, yeah, you can try out Go. Go is not bad language to move around with. Yes, you can also create a page with Golang. So because the endpoint I just created, what I did with this endpoint was just to spit out, what's it called now? JSON. This is just to spit out JSON. You could literally create an HTML page, but of course, that's going to be a lot of work to spit out HTML page, but it's doable, right? Most times when you are creating an API, you just focus more on spitting out JSON data. It's easier so that the front-end person can just work with the JSON data that you have. Okay. So if there's no other questions, I will just continue on the live session on TikTok. So Felix, there's no question. from your end. Okay, so okay guys, let me move on. Now this course is a teaser, right, for the main course. If you're interested in Golang or interested in other courses that we have, so make sure you see the link on the bio and send me a DM. See the link in the bio and send a DM. Very important. Okay, so let's move on to the next thing. Please tag me for